Hello everyone, welcome to TechSmartStudy.com. Let's solve a problem of Maxwell's reciprocal theorem. 800 mm long cantilever with a prop at 500 mm from the fixed end deflects in accordance with the following observations when a point load of 40 kN is applied at its free end, and here the distance from the fixed end is already given and the deflection at each point is already given. So for 0 mm the distance from fixed end is 0. For 100 mm from the fixed end, the deflection is 0.3 mm. For 200 mm distance from the fixed end, the deflection is 1.4 mm. For 300 mm from the fixed end, the deflection is 2.5 mm. And for 400 mm distance from fixed end, the deflection is 1.9 mm. Also, for 500 mm distance from fixed end, the deflection is 0. For 600 mm, the distance from fixed end, deflection is minus 2.3 mm. For 700 mm from fixed end, the deflection is minus 4.8 mm. And for 800 mm from fixed end, the deflection is minus 10.6 mm. So the question is asked, determine the deflection from the free end due to a 30 kN load at 200 mm from the fixed end together with a 10 kN load at 300 mm from the fixed end. Find also the angular rotation of the member and the prop. Let's go through the problem. In the above diagram, the details of the deflection at respective points from the fixed end is already given. It's already stated that 200 mm from fixed end means at D the deflection is 1.4 mm and at 300 mm from fixed end, that is at E the deflection is 2.5 mm and 40 kN load is already given at C, and at B prop is there, and it is asked to find out the deflection at C in the second diagram due to 30 kN load at point D and 10 kN load at point E. Let's calculate. So deflection at D due to 40 kN load at C is equal to 1.4 mm, which is already given, and according to Maxwell's reciprocal theorem, it is asked to find out the deflection at C. So, the deflection at C due to 40 kN at D will also be equal to 1.4 mm. Alright, so deflection at C due to 1 kN load at D is equal to 1.4 mm by 40 according to unitary method, and the deflection at C due to 30 kN load at D which is asked is equal to 30 kN by 40 kN into 1.4 mm, which is equal to 1.05 mm, which is the answer. Again, it is asked to find out the deflection at C due to 40 kN load at E. Let's calculate it. Delta E due to 40 kN load at C is equal to 2.5 mm, which is already given in the above diagram, and deflection at C due to 40 kN load at E will also be equal to 2.5 mm as per Maxwell's reciprocal theorem. So according to unitary method, deflection at C due to 1 kN load at E will be equal to 2.5 mm divided by 40 kN, and the deflection at C due to 10 kN load at E is equal to 10 kilonewton divided by 40 kilonewton into 2.5 mm, which is equal to 0.625 mm. So the total deflection at C under both the action of load, that is 30 kilonewton and 10 kilonewton loads, will be equal to 1.05 mm plus 0.625 mm, which is equal to 1.675 mm. It is the total deflection at C due to 30 kilonewton load at D and 10 kilonewton load at E. And again, it's also asked to find out the angular rotation of the member at prop, that is at B, and in second diagram at B, due to the angular rotation, the triangle BFC is formed, whose deflection, that is FC, we know, which is 1.675 mm, and the distance BC is 300 mm. So angular rotation at B is equal to tan inverse FC by BC, that is equal to tan inverse 1.675 by 300, which is equal to 0.3199 degree, which is the required answer. Thank you.